welcome back. This is Unit 7. Even though on your notes it says Unit 8, if you want to go ahead and change that to Unit 7, that'd be great. This is the mathematics of chemistry, and here's where we're going to begin to apply everything that you just did with sig figs. Although with the first thing that we do, we won't be using sig figs. So I'll tell you when to use them, okay? The first thing you have to know about the math of chemistry is how we can calculate the formula mass and what formula mass really is. Okay? So formula mass has a couple different names. It's also known as gram formula mass, or it's known as molar mass, or it's known as, oops, forgot the mass there. It's known as molecular mass. But in all of these names, you notice you always have mass. So it's really like the weight of the formula is really what it is. And unfortunately, for elements, we can get their weight right off the reference tables. But for compounds, the formula mass is not given in the table. So how can you find the formula mass of a compound? Well, if you were guessing, and you really just add up all the individual masses, then you're right. Okay? So what formula mass really is, and I believe you have a couple blanks to fill in your notes, it's the sum, right? It's the sum of all the atomic masses of all the elements in a compound. So you're going to need a set of reference tables. And again, if you don't have yours with you, then just go ahead and Google a periodic table. Okay? But let me just point out a couple things on your periodic table that you need to be aware of. It's been a while since we talked about where atomic mass is, but notice there is a key. So atomic mass of an element is that decimal number that's in the upper left-hand corner. And what we're going to do is we're going to round that to the nearest whole number. That's why we're not going to use sig figs, because we're always going to record our formula masses to the nearest whole number. Okay? Okay? So if I asked you for the formula mass of lithium, well, that's the same as atomic mass. You would just go here and round it to the nearest whole number. It's 7. And all of these atomic masses are based on, if you notice, carbon-12 as a standard. So we made carbon-12 weigh 12, and then we compared everybody else to it. Okay, so now that we know where to find atomic mass on the table, let's get, I think in your notes you have a couple examples, let's get the formula mass of a compound. Okay? Here's the procedure. You'll list the elements, you'll count the atoms, right, by looking at the subscript, and then you'll multiply the number of atoms by the mass. Okay, again, we're going to round the mass to the nearest whole number, and then you add the values up. So first, let's list our elements. In H2O, remember, every capital letter is a new element, so we list our elements, H and O. Just like when we were balancing equations, we count the number of atoms. So there's 2 atoms of H, and since O doesn't have a subscript, there's 1 atom of O. And then we go to the periodic table and we look up the mass of each element, and we're going to round that to the nearest whole number. So here's hydrogen's mass. We're going to round that to the nearest whole number. It's 1. And if you wondered 1 what, it's called an atomic mass unit. Okay? That's its rounded mass off the table. You don't have to write AMU. I'm just writing it for your information. Okay? And we go to oxygen, and we look up its mass. And we have one oxygen who has a mass of, look at right there, 15.9994, which rounds to 16. Okay, 16 AMUs. So 2 H's, each with a mass of 1, give us a total of 2. 1 oxygen with a mass of 16, and then we add those together. So the formula mass one's a little bit more complicated, mostly because of that symbol, because that symbol in your math class means multiply, but this symbol here really means attached. So this is the formula for what we call a hydrate, and you're going to be working with a hydrate tomorrow in the lab. It's a substance that actually has water as part of its structure. So it's this compound plus 5 waters attached. So I really think you should view that dot not as a multiply symbol, but rather as a plus. Okay, you have copper sulfate and 5 waters. Okay, so again, it's a little bit more complicated because it's bigger, but it's the same idea. You list your elements. Every element, even your polyatomics, you have to break apart because there's no atomic masses of polyatomics. So Cu, S, and O. Every capital letter is a new element. There's 1 copper, 1 sulfur, 4 oxygens. Then I go over here to my water, and I'll list my H and my O. Okay? Now, remember when we were balancing equations, if you have a coefficient in front, it gets distributed to the H, so 5 times 2 gives you 10 H's, but it also gets distributed to your O's. 5 times 1 gives you 5 O's. And now we can go and look up all their masses on the periodic table, okay? Copper, just so you can see what I'm doing, where these numbers are coming from. Copper's right here. Its mass is 64. Sulfur's right here. There's your oxygen, and your hydrogen was back up there. So we've got all the masses. Let's write them down. Copper has a mass of 64 rounded. Sulfur has a mass of 32. And oxygen has a mass of 16. 4 oxygens times 16 gives you 64. So let's add these up. 64, 64, and 32. 160, right? Okay. Then we'll move over to the water and do its mass. Hydrogen has a mass of 1, so that's 10. Oxygen has a mass of 16, so that's what, 80? And when you add those up, I know you can't see that, but it's 90, okay? Just so you could, if you can't read my oxygen, it was 5 times 16 equals 80. So now you add together the 80 and the 10, and that gives you 90. So when the mass of copper sulfate is 160, the mass of the 5 waters is 90. So if you want the mass of the whole compound, you add them together. 160 plus 90 gives you a total formula mass of 250 AMUs. Okay? Atomic mass units. So in your notes, you have a couple practice problems, 1, 2, 3. For tomorrow, I would like you to find these guys' atomic masses. And that's what I'll be checking when you come to class tomorrow. Have a great night, everybody. We'll see you in class. Bye-bye.